Hello, everybody. Thank you all for joining this webinar on the community for PRAESENSA 1.91 release. As you see on the next slide, I would like to notify to you that this webinar is being recorded, so afterwards in hindsight you can still view it. If you have any questions, please feel free to post them in the chat, and then afterwards we will go through the questions and answer them. So if you want to post any of your questions, please use the chat function. You can find it in the right bottom corner of the user interface. Please make sure that you send it to all panelists so that we can see them and effectively address your questions. So today I'm here together with Anton Thiele. Together we will be presenting to you PRAESENSA 1.91 release. And as you see on the next slide, these are the topics that we want to talk about. So first, familiarize yourself. What is this new software release? What are the new features and what are the new application areas? I'd like to give you a short feature overview and also some technical view on a few of new hardware components that we are supporting now with this new software release. And then at the end of the presentation, there will be a short demonstration by Anton. So let's dive into a bit of the feature overview of this new software release. So what is with this PRAESENSA release is actually about becoming more cost efficient in projects in general, and especially also the mid-sized projects. So there will be two new components introduced, as you see in the next animation. The first of it is this small system controller, which is, let's call it the little brother or sister of the large system controller. And it allows us to address projects in the mid-price range more effectively. Then the second one is the Control I/O module, which we also want to talk about. It's a component that we need to add I/O interfacing in the PRAESENSA system in a cost-efficient way. Yes. So let's dive a bit into these two individual topics from a commercial point of view, and afterwards Anton will take you into the details. So what is the purpose of this small system controller now? So if we have a mid-size systems today and we need to quote that system with a large system controller, then the large system controller very often in the bill of quantity is a very expensive component because it's simply over-specified for the job that it needs to do. So there is now a new device. It's called the small system controller. It features the functionality of the large system controller, but it has some limitations. It's limited to 6 amplifiers, and the audio Dante streams are limited to just the 8 ones that are supported by the controller. Yeah. Further, it's the same device as the system controller large. So you can use the APAS. It has all the same features except for these limitations in scaling, I would say. Yeah. So you see in the next animation. So what is the benefit of this? So if we are facing a project where the system is not so large and there are not so many amplifiers inside, then the system controller large might be an expensive component in the bill of quantity, which is making us uncompetitive. So this is why we now have this restricted version to bring a controller into the game, which just matches better inside the bill of quantity or material of a mid-sized project. This allows us to be more cost efficient in these type of projects, as you see here, a mid-sized hotel, for instance. Yeah. So one thing important is the small system controller cannot be upgraded to a large system controller. So it's really two different devices. If you want to have a large system controller functionality in your project, you need to swap the device in the rack. Okay. You see the I/O interface module. So what is the use case of this one? Well, it adds additional input and control outputs in a PRAESENSA system. It is a solution which is EN54 certified. So you will have contacts that you can use an EN54 certified context, and it is used for interfacing third-party equipment. a very often seen use case is, for instance, interfacing to a fire alarm system, which requires also the EN54 certification. And if you have a lot of zones to address, you need additional I/O. Yeah. So what's the benefit of this module? Well, first of all, it's IP based. So you can bring your I/Os very close to the system that needs interfacing. Anywhere in the network where you have the IP available, you can basically plug it in, use it as an IP device, and control it through the system. It's a cost-efficient alternative to the I/Os in the MPS3. Up till now, sometimes if we had to add additional I/O, we had to add additional MPS3 with a lot of MPS3 functionality, which would not be utilized. But now we have a dedicated module which solves that problem. You just install this module, which is merely I/O, and that way you can grow I/Os in your system. It's a PoE power device, so this means you do not have to deal with local power infrastructure and redundancy on that power infrastructure and all these type of things. It's just the IP cable connection, which is featuring the Omnio protocol. You just plug it in, and then the power comes over the same cable, and you are also good to go with all your redundancy, because in the end, the Omnio infrastructure, of course, is a dual connection connected in a ring. Then there is the protection of data. So the control outputs very often trigger critical infrastructure. So to ensure no misuse is taking place there, this data is actually encrypted, so it cannot be replayed into the system for any misuse purposes. And as you see on the next slide, here is a bit of an overview on the feature set of this module. So it's 16 control inputs, it is 8 control outputs, and we have to supervise the triggered outputs for notification devices. And as already mentioned, this device is listed on the PRAESENSA EN54 16 certificate. So with that allows you to build a full EN54 certified compliance system, including this I/O expansion. So going to the next slide, I would like to hand over to Anton now to bring you a little bit into the details of these devices.
Okay, thank you, Maarten, for this good introduction. Let me indeed go a little bit more into the technical view, especially on the Control I/O module. For the Control I/O module, you have here the front panel shown, where at the upper left side you see the indicators for power on, for if there is a fault in the device, if there is a link to the issue with the system controller or not. So if there's a ground fault and there is a reset button. This reset button is similar to what you may be used to for resetting other PRAESENSA devices. There is then the other network ports, the PoE in power, as explained by Maarten already. And you have then in the middle the control inputs, so the 16 control inputs with a status indicator. So like the MPS is not showing really the actual status of these control inputs, this I/O module does provide us with these LEDs. And then you have the control outputs, where you have your 8 control outputs and your A and B monitored output, with also a status indication if that control is activated or not. And then you have the, so this AB, what I just mentioned with the status indication. So for the reset button, if you activate it below 10 seconds, it will act like an indicator test. So the LEDs start blinking. If you press it more than 10 seconds, then you bring this device back to factory defaults. This means that it will lose the encryption key and that you need to reassign the device to the system. All LEDs blinking indeed means then that it is in the identification mode. So which type of functions do you then have for this module? Actually, it is similar to what you have already on the MPS. that are like when you look at control input, you can do a make announcement function. You can start a phased announcement. So when you have one message player somewhere praying an evac, and then you can add additional zones to it by means of contacts, and you can stop phased announcements. So you can reduce the number of zones where you have an announcement running on the fly. That's what these phased announcements do. Then you have a silence zone option, so you can, with a contact on a particular priority, block the audio in a zone, in a specific zone based on that contact and configured priority. So you could introduce an external fault into the system, which is then reported and through the logging server and the call station. So furthermore, you have then an external zone fault indication to trigger. You could trigger a main supply fault from external, which would mean that, for example, if you have an UPS externally or an external fan, which you would like to be reported inside PRAESENSA, then you can also use this main supply fault trigger to indicate there is an issue externally, and it also will behave accordingly. So that means that it will go into also into a power save mode. You could directly trigger that through that power save mode as well. And then you have the acknowledge and reset option to reset faults or to switch a control output somewhere maybe on another module. And you have music control options here with these control input functions. So you can assign really a lot of different type of functionality to the control inputs. Then for the control output functions, you have then a switch output triggered on an input somewhere or based on a zone activity. Besides activity, also on the priority, which is assigned to that zone. So maybe, for example, that you're only on a zone 1, say only when it's in an evac status, that you then get the control output activated or not. Furthermore, you have then the fault alarm buzzer and indicator, the emergency alarm buzzer and indicator control outputs, and a general system fault indicator or a general power fault indicator. So these are the control in and control output functions. Besides that, we have then these two A and B control outputs. These are supervised trigger outputs, and they are especially for the UL market interesting because of the fact that you can now also supervise these NAC devices. So like these NAC boosters for indicators, for example. So this connection supervision reverse the polarity to be able to be sure that that the connection is still there, and in a normal operation mode, then it activates the horns or the strobes which are connected to that booster. So the supervision works then like you in an inactive mode. It can supervise through this 5 volt over this 10K resistor here at this side. When you would have here 12 volt applied, that in this case you are sure that the NAC booster is active. So we are using a 10K resistor, 10 kilo ohm resistor, which needs to be placed between the connections of the booster. When you are in an active mode, then there is this minus 12 volt available from the module to be inserted into the NAC booster to activate this opto coupler to activate the booster and to trigger it. So you cannot have them both at the same time. So it's either an active booster here, or it is in a supervision mode. Further in supervision of the I/O module are the internal processes, the PoE power on both network ports, and an optional ground short. So when you look at the control inputs, it's similar to how the inputs are monitored from a multifunction power supply, the control inputs over there. So you can place two 10K resistors in series, and on the second one, you position your switch, and with that, you could have a supervised connection. Yeah, don't use common lines to wire the contacts. That's not appropriate here because of the fact that we also need to be able to have this supervision in place. Yeah, then you have this control output, which can then connect to the neck booster. These supervised options are available within the I/O module. Yeah, the mechanics and power. Yeah, it's a compact housing. It's a DIN rail TS35 mounting, and the connections are then only this dual RG45 for the redundant network connection. PoE, yeah, you cannot loop through PoE, so it's only direct. It's only a power device on both sides. For the connections, you will using this pluggable spring cage terminal blocks for wire connections. So that's about that one. The PoE power is less than 4.2 watts, and it's a default PoE source which you can use, like the MPS3, which has two PoE ports where you can directly connect this device to, or from a network switch like the ES8P2S. Both these ones, these MPS and the ES8P2S, are EN54 certified. You could also use from a midspan injector for PoE supply, but then your connections to this device are not anymore EN54. So maybe for other purposes you could still use it, but not then for EVAC related aspects. Yeah, related to the network, we are using, as already told, the Omnio connection, so open control architecture, which means that all control can be encrypted and passed through the Ethernet connection itself via the RG45. And the data is encrypted by TLS. And it uses rapid spanning tree support, which means that you can loop the devices. So you can create a loop of, yeah, like a ring of devices. And if one link is interrupted, then still the devices can communicate with the system controller. Some icons which are available. We have some visual icons added to the visual list to create designs. You can use them, or we have also this general icon which is available for you to use in your designs. Yeah, with the controller indication in the device, the control inputs, control outputs, the supervised outputs, and yeah, in this case, the network connection. All right, so yeah, let's briefly show you how this then looks like. I have here a system in front of me, where you see here at the right side here, you see the I/O module. I have a couple of contacts I have connected here. I have in this time now only one PoE port connected. And I have here in my test track some control I/O here, these ones, where some of them are connected to the I/O module control inputs. Yeah. Furthermore, I have here a main and redundant system controller. That's this place, and here some amplifiers. Yeah, and just for here a call station to show you. So let me first try here to make a call, and just generally I select here three zones, and when I make a call, you can now see. So I'm now having the call run active. You can see here at the right side that we have 3 LEDs active of the 3 zones I have selected. When I disconnect, then the LEDs are gone. And now when I activate them again, you can see here that I have the 3 zones active, and also the A and B, maybe for external strobes, are then at that moment active. Yeah. So reset from evac mode again. So that's the interaction what you have there. You could also have here like
attention please.
particular message.
Due to an
Now,
emergency,
control
it is
input.
necessary to evacuate the building.
Stop it again. So you could see that you have here the control input. That's this one, number 9, which I connected to number 1 here of the module, which triggers
Attention please.
contact 1 here and
Due to an
contact
emergency, it is necessary to evacuate the building.
This one is
Please
connected
leave
to
by the
zone
nearest
1,
exit.
so you can also see
Do
what
not
it
use the
calls.
lifts.
When I have a second control input activated,
Attention please.
you see now input
Due to an emergency, it
It's
is
assigned to go
necessary
through.
to evacuate the building.
and we have B.
Please leave by
So
the
you can
nearest
see
exit.
also on the
Do
screen
not use the lift.
what is happening over there.
Attention.
So that's briefly the activity what you can do. I have this is also a control input which is at the moment connected to the MPS, but you could have a similar function here that you have an external main supply fault. What you see now is, for example, that you have the amplifiers here giving a blue LED. That means that the system gets into a snooze mode. So the power is now reduced of these, and at the moment, because there's an external mains fault, for example, if an UPS is now active, so it's immediately into the snooze mode. If you want to make a call still for the emergency, or maybe for 2 zones. So now you see the amplifier, where the zones are going to is active again, and the others stay in their snooze mode. And then I stop the call, and now you see it's getting back into the snooze. Yeah? Until the external mains fault is recovered, or that you regularly have to do some checks on the loudspeaker lines, and then when it's recovered again, you see now everything gets green again and it's active. So this kind of control you could also deploy on the IO module. Yeah, that was about the demo I would like to show you. So are there any questions?
Okay, Anton, thank you for the demonstration. I don't see any questions in the chat yet, but let's give it some time. Maybe something still comes. Please, if you pose the question, make sure that you address it to all panelists so that both me and Anton can see it. Okay. Seems no questions are coming in there, Anton. Then I guess it was all relatively clear. Yeah, if there are no questions, Anton, thank you for supporting and presenting and demonstrating. And for everybody who joined, thank you for your attention. Yeah, then hope to see you next time and wish you already. Oh, there comes a question in. Good. You did not mention the need of the 1.91 software for operating the PRAESENSA IM1 module. Okay, this is a good point.
Yeah, that's a good one. Yeah, that's right. I forgot to mention this. It's actually pretty important,
Yes.
but it's also labeled or mentioned on the device. This unit really needs firmware 1.91. So that's important for this unit. And there are previous versions which, so like 81, which would really break the device. So it's really mandatory to use 1.91 here to work together with this module. So it's indicated on the label, but important to be sure that you choose the latest firmware, this 91 firmware.
Yeah, okay. Thank you for this remark, Paul. Indeed, it is important. Yeah, I guess that's it. Okay, if there are no further questions, then I wish you all a good weekend and hope to see you again joining on the next webinar that we will host. Thank you very much. Bye-bye.
Thank you. All right.